Hello, this is Vasavi from At Home. So in this video we are going to learn how to solve the pair of linear equations in two variables graphically. As I told you earlier, you would have a pair of linear equation, right? So you would have two equations here because it is for two variables. You have two variables in the equation, right? So you would normally, in the question they would give you two equations. Let's see how to solve this. So first, let's take the first equation, x plus y equals 3. Here we can have infinite solution for this. As the x changes, your y also changes, okay? So you can have infinite solution for this. But here I just make a table here on which I'm going to just find out few of those values so that I can plot them in the graph, okay? So first I take when x is 0. When x is equal to 0, what happens? Just plug in the value of x in the equation, so you would get 0 plus y equals 3, right? So you get your y as 3. Understood? Your y is 3 here. So let's write down that when your x is 0, your y is 3. Let's give some other value for x. So let me take when x equals 2, okay? You can give any values. So accordingly your y also changes. So this will be 2 plus y equals 3, right? In the equation when you put the value of x, you get this. So your y would be 1. That is 3 minus 2, which is 1, okay? So this is your next set of ordered pair. You call them ordered pair. So when your x is 2, your y is 1. So and now let's take the y value as 0, okay? When y equals 0, what happens to your x? So it is x plus 0 equals 3, right? X plus y equals 3. So here you have taken your y as 0. So that is x plus 0 equals 3. And hence your x is 3. Okay. When y is 0, your x is 3. Did you understand how I got this table done? Now let's go plot this in the graph. Okay. Let's finish this off in the graph. You have got a graph here. So let me plot all those values. The ordered pairs, you can write the ordered pairs. That is 0, 3. This is one ordered pair. And the other one is 2, 1. And the third one is 3, 0. So let's plot that. First I'm going to plot 0, 3 in the graph. So here your x is 0 and your y is 3. So when x is 0, your y is 3. So it will be over here, right? This is the spot. When your x is 0, your y is 3. Then you have when x is 2, the next ordered pair is x, 1, right? So when your x is 2, your y is 1. So that comes here, okay? And finally, when your x is 3, the last ordered pair was when x is 3, your y was 0. So now you got these 3 points marked. So let me write that here. This is 0, 3. Okay. And here this is 2, 1. Just see when you add them up, you're getting the 3. So it is satisfying your equation. So that's 3, 0, right? So use your line and then just join them, okay? So your line, just extend as much as possible. So it is like this, the linear. Yeah, so I've just plotted this. Okay, I can also write here, this equation is for x plus y equals 1. Got it? Yeah. Now, come back to your table. Second equation you have is x minus y equals 1. It is given in the question, okay? So again the same thing, when x is 0, what happens to your y? Your y would be 0 minus y equals 1, right? So your y is negative 1. You can plot that first. So these two, let's plot. When x equals, this is for x and this is for the y. And when x equals 0, your y is negative 1. Now let's do when y equals 0. Okay, next let me take y as 0. So what happens? It is x minus 0 equals 1. So your x is equal to 1. So when y is 0, your x is 1. And finally you can have one more number. You can use any number, okay? There is no restrictions like, So let us take when x is some 3 or something, okay? X is equal to 3. So what happens? This is 3 minus x equals 1, right? So your minus x would be 1 minus 3. So that is minus 2, okay? So your y will be, negative y is minus 2, so your y is equal to 2. Understood? So when you take your x as 3, your y should be 2. This is for x minus y equals 1. And this one is for x plus y equals 3. Right? That we already plotted. Now I'm going to do this second one in the graph. Okay? So that is, the ordered pairs are 0, negative 1, 1, 0 and 3, 2. Okay? So let's plot that in the same graph in which we had done already. So now here, what was your value? Your x is 0 and y is negative 1, right? Yeah, the first one is x is 0 and negative 1. Let's plot that. Your x is 0 and y is negative 1. So that would be here. Let me write the ordered pair there immediately. So that would be 0, negative 1. Okay. And the next number is 1, 0. Let's plot that too. So it is 1, 0. So it is here, right? Your x is 1 and your y is 0. So this is 1, 0. Okay. And finally, the next one you had was 3, 2. Let's plot that too. 3, 2. So when x is 3, your y is 2. So that is here. That's 3, 2. Okay. That's 2. Okay. Good. Now let's join them too. Okay. Using the line, you can just join them. Draw a straight line. See, those points should coincide. You got this equation, and this equation is for x minus y equals 1. Okay. See where it meets, where the two lines intersect. So the two lines intersect here, right? I am using a red color to point out. So this is the place where the two lines are meeting. So the value over there, your x is 2 and your y is 1. Okay, see? You can see there, right? So the solution is your x equals 2 and your y equals positive 1, right? So that's your solution and you got it. Understood? So here I would like to tell you one more thing. There are only 3 possible situations, like solutions for these graphical representation. When you solve for 2 linear equations in 2 variables, there are only 3 possible answers you can get. One is, here I have mentioned all the 3 here. One is the independent system. It is independent because they are two different lines, but they just have one solution in common, one point where they meet, and that point is your solution. So here you have two independent lines meeting at one point and you have one solution here. Understood? So that is what we got in the previous sum. You had one point of intersection, right, where the lines meet. The second one is inconsistent system. You call it inconsistent because these two lines are parallel lines, okay? How much ever you extend, they are going to be the same. There is no change in its distance and they still remain the same distance how much ever you extend. So you do not have a solution for it, and that's why you call it inconsistent, okay? So here you had one solution when they meet. That meeting point is one solution, and it is an independent system because there are two different lines. They are two different lines meeting at one point. Now the third one is dependent system. You call it dependent system because the one line is on top of the other. Both the lines would overlap, okay? So here itself you have both the lines where all the points on the line is common for both, okay? And you have infinitely many solutions for this because right from the top of the line till the end everything coincides. Here you have infinitely many solutions, okay? If the lines are parallel, then there is no solution, and when the two lines intersect, you will have one solution. And I hope you understood how you solve it graphically, right? We'll do more problems on this in the coming videos. Bye. Take care.